What's up, everybody? Welcome to Earth Science. It's time for the Igneous lab. I'm going to take a minute and showing you how this all works because we're basically going to be doing the same lab a couple of times, just with different rock types. But it's all set up kind of the same way, so that once you do the first one, second one, and third one will be a lot easier. So let's slowly make sure we understand what's going on here, so we can start. All right. So you've got a assignment called Rock Labs. It's already loaded in the Google Classroom. It's been there since last week. And follow the survival guide. You'll get to the there's links for all of it, But within that, there's going to be all three labs. I just did this rather than having three separate assignments because the gradebook's starting to get kind of giant. And it doesn't matter because I'm not going to do any grading right off of these documents. It'll be off the ones you actually work on. So the way this is going to work is these are basically like if you were in class, I'd hand you a tray full of rocks and you do your work with them, right? So we can't do that here. It's got to be online. So these are your virtual trays of rocks. So the first one we're doing is the Igneous lab. You'll open that up, and basically these are your rocks. Now, if you have to have done the notes to get into this. And I showed this document already, you would have seen this. If you haven't gone back and done those Igneous notes, please don't jump straight to the lab. This one will go right over your head instantly. Unless you already know what like felsic and mafic compositions are. So make sure you did that. And then here's your 8 rocks. We're going to work them in the lab. Okay. So let's find the lab, which with my way too many tabs here. There we go. So here's what you're going to have to do. There's your 8 rocks. And these are the things I'm going to expect out of you for each one of them. Use the text box tool. You can get through here pretty quick. But is it light, is it dark, or is it in between? And remember, with the light ones, that we're going to want to probably see a little bit of pink in there at least. Dark will be dark, pretty easy. In between, is it gray, or is it about 50-50 black and white? Composition based on that, again, this should be something you got down in the notes. The lighter colors with pinks, the composition is felsic. The darker colors, the composition is mafic. And the 50-50, granted, this is not printed on this reference table, but we call those intermediates. So is it, you could even do F, M, and I if you want to. F for felsic, M for mafic, I for intermediate. Save some typing. The texture, what do you see? Is it coarse? Coarse means that there's visible bits. You'll be able to see them. Fine means that they're all pretty darn small. So you pretty much can't lay eyes on like naked eye on the individual crystals. But again, watch that previous video. I covered some of this. Vesicular is gas pockets. Glassy will look like a hunk of glass. And then the cooling history is based on that. So really, it's as simple as coarse. Those are your intrusive, slowly cooling ones. Fine vesicular and glassy are all extrusive, quickly cooling ones. Then give me the rock name. And if you watch the video, you'll see how to do that. So is it intrusive, extrusive, or that really aligns with, is it coarse, fine, vesicular, or glassy? And then is it over here on the left for felsic, over there on the right for mafic, or in the middle for intermediates? Why don't I'm going to be nice. I'm going to tell you the 8 rocks I have on there. Let me pause and circle them so that I don't fumble around here for. All right. So that you didn't have to watch all that fumbling around. There they are. So there's your 8 rocks. Note that this one usually appears black. That one's a little bit of a screwy thing. Again, I mentioned that in the previous video. So those are the 8 you're going to look for. Those are your 8 answers, but it is up to you to figure out which ones are which. Okay. This is one of the more complicated reference tables, but the rocks tend to be very like the features that make them unique tend to be pretty easy to spot. So I think you can do it. Okay. The last column on that lab will take a minute, but you can do it, is once you get the rock name, what minerals would you find in that rock? So whichever one you say is granite, granite has the minerals that are right below it in it. It has potassium feldspar, quartz, plagioclase feldspar, biotite, amphibole. Yes, I usually do make students write all of those. Yes, they complain because they're using a pencil and trying to write in tiny letters. Your life is easier. Just type it. And then you can, if you're, you can figure out how to do that for all these rocks. And just make sure that you only do the ones that are in it. Like if you're telling me granite has pyroxene in it, you're wrong. We're not speaking the same language. Granite would have these minerals in it. Okay. Whoops. Want to do erase. All right. Sound like a deal? So that'll get you that whole thing. Questions are basically write things out of the notes. Cooling history and crystal size. Tell me about like slow versus fast. And then you're going to need that idea again down here. Mafic has what elements? That's in the reference table. Felsic has those. Mafic has those. So Hawaii is a volcano. Mount St. Helens is a volcano. That's the key to this question, and that's what screws people up is they don't realize that, oh, we're talking volcanoes. If Hawaii is a volcano, it's extrusive rock, dark in color. What would make up Hawaii? If Mount St. Helens is extrusive rock, light in color, what rock makes up Mount St. Helens? Or same deal here. Vermont, they dig down to a big intrusive body for that mine and get a coarse green felsic rock and sell it to countertop companies and memorial companies, things like that. Lastly, what do we got here? This would be, so occasionally magma, as it's working its way towards the surface, contacts other rocks, right? So what I'm saying here is that if it's touches older rock that's already cold, if you're magma, on the outside, if it has a fine texture, but towards the middle has a coarse texture, why would that be? You got to come up with an explanation for why that would be. And hint, hint, it has a lot to do with the idea that this older rock over here is cold. All right. And it really has a lot to do with question one. If you can get question one, this is only a tiny little leap of, I don't know, a little conclusion. But you can do it. You guys are going to nail this. All right. And that'll be the format for all of them. So the next we'll move into sedimentary, do some notes, do a lab with the same documents, and then we'll do it with metamorphic and keep this thing moving. All right. Keep up the good work, folks. Good luck.